So we're back looking at ionization energy again, but this time we're trying to look at the big picture and how it fits into the periodic table. So the periodic table is arranged the way it is for a reason. It helps us discern trends. So we're going to try to figure out what those trends are. So if we look at first ionization energy here. So the fact that it's first ionization energy, that means the energy it takes to just pluck off that first electron. So we're not worried about the rest of them. We're just worried about that first electron. So first, let's look within the groups. So you'll see it's always going up. So that means across the periodic table, ionization energy is increasing. And that's because as we go across the periodic table, we're adding more protons. So that means the positive pole is stronger, your well is deeper, so that nucleus is holding on to those electrons a little bit tighter. So it takes a little more energy to pluck them off. So again, as we go across the periodic table, we're adding more protons. That means the pull from the nucleus is stronger, which means it's a little harder to pluck off the electrons. It's making a deeper well. Now, let's look here. I just want to look at the first one in each row for the periodic table, because remember, these jumps represent rows on the periodic table. So I go here, to here, to here, to here. So as I go down the periodic table, my ionization energy is actually decreasing. So it's going down. The overall trend, while it's going up within the groups, the overall trend is actually a downward trend. So that's because as we go down the periodic table, we're adding levels. So we're adding energy levels, which makes it a little easier to pull off those electrons. So it takes less ionization energy because the electrons are further from the nucleus, so they're a little easier to pluck off. They require less energy. So going across the periodic table, add more protons, stronger pull from the nucleus, more ionization energy. As we go down the periodic table, we're adding energy levels, so that's a bigger distance. So it takes less energy to pull off those electrons. Okay, so let's look at atomic radius now. So atomic radius, again, you can see these groupings. So as we go across the periodic table, that's within these groups here. So as we go across, you can see atomic radius is going down. So atomic radius is going down as we go across the periodic table. And that's because we're adding more protons. So that positive charge from the nucleus is actually pulling those electrons in closer. So we are adding more electrons, but that big positive nucleus, it's got a bigger attraction. So it's squeezing in those electrons, pulling them in closer to the nucleus. So more protons as we go across means the atom is actually shrinking a little bit in size because that big positive nucleus is pulling the electrons in. But we can see it's an overall positive trend. So as we go down the periodic table, overall the atomic radius is actually going up. So as we go down each row, the atomic radius is going up. So that means that we're adding energy levels, right? We know we're going down, we add energy levels, that makes the atom bigger. So as we go down the periodic table, we're moving out with the atom adding more energy levels. Our electrons are moving further from the nucleus. So that makes a bigger atomic radius. So going across, more protons pulls the electrons in. Going down, more energy levels builds the atom out. And lastly, we've got electronegativity. Now, electronegativity is going to follow a similar trend to ionization energy because they're definitely related. So electronegativity is referring to how well an atom can attract electrons. We talk about electron affinity. Electron affinity and electronegativity are very closely related as well. So again, you're going to see we've got going across the periodic table, we've got this positive trend. So electronegativity goes up as we go across the periodic table. And you got those more protons. Always remember, across the periodic table means more protons. We got a bigger positive charge. That bigger positive charge is going to pull on those electrons. So we're going to get a stronger attraction between the nucleus and the electrons if we have more positive charge in the nucleus. And then going down, we have that overall decrease in electronegativity. because again, it's the same reason as the ionization energy. You're building out those energy levels. So as electrons are further from the nucleus is not going to have as strong of a pull, as strong of an attraction on the electrons. So going across, electronegativity increases, bigger positive charge from the nucleus. Going down, electronegativity decreases. Electrons are further from the nucleus, therefore weakening the attraction. Just like if I had two magnets that were far away versus two magnets that were close together. Remember, distance matters. So this last slide is just a little summary slide for you. So atomic radius decreases across, everything else increases. Atomic radius increases down, everything else decreases. And that's your periodic trends.